Real photos, real AI on your phone. In this episode, you'll take the cat and dog classifier from our last video and run it on a real Android phone with LiteRT, the new name for TensorFlow Lite. Convert, quantize, build an app, and watch it classify live. Let's get started.
Quick recap. Last episode, we built a cat and dog classifier that reached nearly 98% accuracy. CNN, data augmentation, transfer learning, fine-tuning, and in the outro, we made a promise: run it on your phone. This episode, we keep that promise.
Why run AI on the phone at all? The cloud needs internet, uploads your photos, and adds latency. On device, the model runs fully offline, your photos never leave the phone, and answers are instant. Google says LiteRT powers over 100,000 apps on 2.7 billion devices.
Step 1. Convert. In Colab, we load the trained model and strip out the training-only augmentation. One converter call writes model.tflite, about 13 megabytes. The input tensor is 1, 160, 160, 3, and the output is a single probability.
Step 2. Make it small. Dynamic range quantization shrinks the model to about 3.5 megabytes, 4 times smaller, with almost no accuracy loss. Full int 8 needs a representative dataset, 100 images. For this app, we ship the dynamic range model.
Step 3. Android Studio. New project, empty views activity, Kotlin, minimum SDK 24. Add the LiteRT dependency, version 1.41, which keeps the classic interpreter API. And remember, no compress must include tf.lite. Then sync.
Step 4. Load the model. Put model.tflite and labels.txt in the Assets folder. One line creates the interpreter. The input expects 160 by 160, and the output is 1 probability. Without no compress, the model simply won't load.
Step 5. Connect the camera. Each frame gets resized to 160 by 160, copied into a float buffer, and fed to the interpreter. The model normalizes the pixels itself, so we never normalize again. Run it, read the probability, and show the label.
Time for the demo. Pick a dog photo, 99.1% dog. A cat photo, 98.4% cat. Live camera, it updates every frame fully offline. That's the model we trained, running in your pocket.
If it breaks, here are the 4 fixes. Compressed model file, add no compress. Interpreter missing after upgrading, stay on 1.4x. Buffer size mismatch, resize to 160. And if it always predicts the same class, you normalize twice.
Want it faster? Enable the GPU delegate. 22 milliseconds on CPU, 8 on GPU. In 2026, LiteRT's GPU is 1.4 times faster than before, and NPU acceleration is production ready. CompiledModel API is the modern path.
That's the full journey. Convert, quantize, build the app, run the demo. Next episode, we train on your own photos, a custom dataset classifier. If this helped, like, subscribe, and comment. What should the AI classify next?